Okay. All right. So what we're going to do now is we are going to apply those three theorems that we talked about above. Okay. So here's the first thing that we have to do, though. If we read those directions, okay, what this is first saying is determine whether each set of numbers can be measures of a side of a triangle, meaning does the triangle exist? So the first thing we have to think about, all right, is would the triangle exist, all right? So what that means is, remember when we talked about this in chapter 5, is we have to check to see that if we take the two smaller sides and add them together, are they greater than that third side? So if we look at 7, 14, and 16, all right, if we added 7 and 14 together, we'd get 21. Is 21 greater than 16? Yes, it is, all right? So we can now decide if it's acute, obtuse, or right. Okay, so to do that, 16 would have to be our hypotenuse because it's the biggest, okay? So I'm going to start there. So I'm going to do 16 squared, and I'm going to compare that to 7 squared plus 14 squared. So 16 squared is going to be 256, okay? 7 squared is 49, plus 14 squared, which is 196, okay? If I add, so I have 256 first of all, compared to, and then if I add the 49 and the 196, I'm going to get 245. Okay? All right, so from there, 256 is greater than 245, and if it's greater than, I know I have an obtuse triangle. Okay? That's it. All right, it's pretty simple. Let's try the next one. So we have 9, 40, and 41. All right, 41 has to be my C. So I'm going to take 41 squared, compare that to 9 squared plus 40 squared. Okay, first thing I should have done is actually check to make sure that the triangle existed. So if I add the 9 and 40 together, is that greater than the 41? It is, okay? All right, so 41 squared is 1,681. And I'm going to compare that to 81 plus 1,600. All right, I'm going to bring down my 1,681 in comparison, and then if I add these two together, I get 1,681. So these are equal to one another. So if that's the case, then this is going to be a right triangle. Okay? All right, let's come down and do this one right here. Okay, so if we added the 6.2 and the 13.8, all right, so 6 plus 2 plus 13.8 would give us 20. Now, what we're doing right now is we're checking, all right, to see if this triangle exists. Do we want this number to be greater or equal to 20 or just greater than 20? Well, the answer to that is we want it to be just greater than 20. So in this case, the triangle doesn't exist. Okay, so if you want to save yourself time sometimes, you want to definitely check that first, all right, because it's not always going to exist, okay? Let's try this one. Okay, so 3, 3, and then the square root of 18, okay? The square root of 18 is going to be approximately 4 something, all right? Like 4 point something. So we know that this has to be our C. Okay? So I'm going to plug that in. And so I'm going to get the square root of 18 squared in comparison to 3 squared plus 3 squared. Okay. So squaring a square root actually takes that away, takes the square root away. So the square root of 18 squared is just 18. In comparison to 3 squared, which is 9, plus 3 squared, which is 9, all right, which gives us 18 in comparison to 18, which is equal. So in this case, again, we have a right triangle. Okay? All right. Let's do one more. I actually want to change this one because I want to do one more example, but if I added 9 and 5 together, I would once again get 14. Is 14 greater than 14? No. So the triangle wouldn't exist on this one. So let's do one more example, all right? Let's just do something as simple as like 2, 3, and 4, okay? Actually, let's change that. Let's do 2, 3, and 3, okay? I'm not exactly sure how this is going to work, but we'll see. So we have 2, 3, and 3, all right? If we add any two of the sides together, is it greater than the third side? It is, all right? So we are good to go. So either one of these C's have to be my hypotenuse, all right? So let's say that this is my C, okay? And so I'm going to do 3 squared in comparison to 2 squared plus 3 squared, okay? All right, we would get 3 squared, which is 9, in comparison to 4 plus 9, okay? 9 in comparison to 13 is less than. So in this case, we would have an acute triangle, okay? All right, I hope that made sense. If not, make sure you come see me during office hours. I think it was a pretty quick lesson, but let me know.